Welcome to my video lesson based on utilization of electric power. Paper code EE702. Today I will start with a new module based on electric heating, and my introductory module is on Introduction to Electric Heating. Myself Kumran Banerjee, Assistant Professor of Electrical Engineering Department, Dr. Sudhir Chandrachud Institute of Technology and Sports Complex. Previously, it was known as Dr. Sudhir Chandrachud Degree Engineering College. This institute is under GIS Group. So, today we will start with a new module on electric heating. For daily purpose, we are using different kinds of electric heating materials for heating purposes, such like electric iron, like micro oven or induction oven, rice cookers, many more things are there which can utilize for heating purpose, and that is done by electric heating. So let us start with our topic, that is based on electric heating. So, electric heating is basically the application of electricity produced heat is on a rise because of its economical aspects and availability of electrical energy. Electrical heating is widely used for both domestic and industrial purposes. Domestic applications like room heaters, immersion heaters for water heating, hot plates for cooking, electric kettles, electric irons, popcorn plates, electric oven for bakeries, electric toaster, etc. Industrial application of electric heating include melting of metals, heat treatment of metals like annealing, tempering, soldering, brazing, etc. Thirdly, modeling of glass, fourthly, baking of insulators, and fifthly, enameling of copper wax, etc. These are basically comes in terms of electric heating. So, what is the basic advantage of electric heating? As compared to other methods of heating using gas, coal, fire, etc., electric heating is far superior for the following reasons. First of all, cleanliness. Definitely, when we are using electric heating, cleaning is much better. There is no matter of conversion of a particle like coal or gas or anything. There is no particles are there, so there is no matter of exhaustion of gases or any kind of flues like that. So it is absent of dust, ash, or the fuel charge never gets contaminated. Secondly, absence of flue gases. In the absence of flue gases and soot, atmosphere and charges are not polluted. We thus get clean and hygienic operation. Thirdly, easy of control. You can easily control the temperature of charges either manually or make fully automatic. You can also adapt any heating and cooling cycle. Fourthly, economical. Electric heating is economical because of electric furnaces are cheaper in their initial cost as well as maintenance cost, since they do not require big space for installation or for storage of coal and wood. Moreover, there is no need to construct any chimney or to provide extra heat installation. Fifth, better working condition. As the radiation losses are low, working with electric furnaces is convenient and cool. Moreover, these furnaces are noiseless in operation also. Sixth, Easy of adaptation. Electric heating can be adapted easily to our requirement of the heating, such as heating local spots or heating materials uniformly. 7. Very high efficiency of utilization. In electric heating of heat can be brought directly to the point where heat is required, thereby reducing the losses. So I have discussed the advantage of electric heating, and for daily purposes we are using different materials or different devices for electric heating purposes. Now you can see there are lots of advantages of electric heating, and apart from those there are also several points are there for electric heating purpose, like uniform heating. In all methods of heating by burning fuels, heat is to be conducted from the outer surface of the material to inside of the material. Thus, inside of core material comparatively remain cold. By electric heating, it is possible to generate heat inside the core of the material. Thereby, uniformity in heating is closely achieved. 9th, heating of non-conducting material. It is possible only with the electric heating. To get non-conducting material heated uniformly throughout the section. This is possible because heat is generated inside the material itself. And last point, that is safety. Electric heating is quite safe because it responds quickly to the control of signals. So, all these points, total 10 points I have discussed about the advantage of electric heating. And based on these advantages, generally the electric heatings are normally chosen for different kind of operations as per their suitable arrangement. Now, heating methods. There are several methods for heating purpose also. So, firstly, it is divided into two types, that is power frequency heating, and secondly, high frequency heating. So, power frequency heating and high frequency heating. Then, power frequency heating is again divided into two parts, that is resistance heating and arc heating. Resistance heating is divided into three parts, that is direct resistance heating, indirect resistance heating, gradient heating. And arc heating is also divided into two parts, that is direct arc heating and indirect arc heating. Apart from these two types of heating, resistance and arc heating, there is electron bombardment heating and induction heating. And high frequency heating also includes two types, that is induction heating and dielectric heating. These are the all heating methods are generally used for electric heating purposes. So let us consider resistance heating, where electrical current passes through a resistance, power loss takes place thereafter, which appears in the form of heat. We know that power loss equals to I square R watts, that is VI or P square by R watts, okay? Where R is the effective resistance of the element. Unlike induction and dielectric heating, resistance heating works equally well with low voltage and low frequency supply, even with DC. In resistance heating, all the energy given to the heating element is converted to heat, and there is loss of energy only in delivering the converted energy from heating element to heating load. In frequency heating, there is loss of energy at two stages. First, while converting power frequency supply, and second, while transferring high frequency power to the heating. Okay. Thus, overall efficiency of the resistance heating is high. This makes resistance heating competitive with other methods of heating employing fuels. In addition to the above, resistance heating method is favored on account of uniform power demand, giving a good load factor and almost unity power factor. So these are the points and how the resistance heating is actually operated. That thing is highlighted here. So now direct resistance heating. In direct resistance heating, the material or charge to be heated is treated as a resistance and current is passed through it. The charge may be in the form of powder, small solid pieces, or even can be liquid. The two electrodes are inserted in the charge and connected to either AC or DC supply as per the figure. See, here this is a liquid forms in here. This part, here the charges are moving, and this is the high resistance powder. It is put above, and two electrodes are inserted here, like this. Now, obviously, two electrodes will be required in case of DC or single phase AC supply, but there would be 3 electrodes in case of 3-phase supply. When the charge is in the form of small pieces, a powder of high resistivity material is sprinkled over the surface of the charge to avoid direct short circuit. Heat is produced when current passes through it. This method of heating has high efficiency because the heat is produced in the charge itself. So this is the direct resistance heating method I have discussed here. So, we can see that in direct resistance heating, in the furnace, 2 electrodes are inserted in the small solid pieces or even in the liquid powder form, and above that a high resistance powder is put there, and we can give the electric supply maybe DC or single phase or 3-phase. Next one is indirect resistance heating. Here electric current is passed through an element of high resistance. Passage of an electric current through resistance produces a power loss, specifically I2R loss, which manifests itself in the form of heat. Heat is then transferred from heating element to the charge, mainly by radiation and convection and rarely by conduction. Sometimes resistance is placed in a cylinder, which is surrounded by a charge placed in the jacket as shown in the figure. This arrangement provides uniform temperature. Moreover, automatic temperature control can also be provided. Example of indirect resistance heating will be found in room heater, hair dryer, soldering iron, flat iron, immersion heater, hot plate, frying pan, electric kettle, electric toaster, electric water heater, electric oven, etc. So, indirect heating is just passing like this one. We can tell that this is a type of electric indirect resistance heating. So, mainly I2R loss, this is act in the picture in case of indirect resistance heating or any kind of resistant heating. The main fact is I2R loss, and that I2R, this power consumption is utilized here. So, in case of indirect resistance heating, the same factor is utilized. Now, requirement of good heating material. Why we need good heating material? Indirect resistance furnaces use many different types of heating elements for producing heat. A good heating element should have the following properties. First of all, high specific resistance. When specific resistance of the material of the wire is high, only short length of it would be required for particular resistance and hence heat. Or for the same length of the wire and the current, heat produced will be more. Secondly, high melting temperature. If the melting temperature of the heating element is high, it would be possible to obtain higher operating temperatures. Thirdly, low temperature coefficient of resistance. In case the material has low temperature coefficient of resistance, there would be only small variations in its resistance over its normal range of temperature. Hence, the current drawn by the heating element when cold would be practically the same when it is hot. Fourthly, high oxidizing temperature. Oxidation temperature of the heating element should be high in order to ensure longer life. Fifthly, positive temperature coefficient of resistance. If the temperature coefficient of resistance of heating element is negative, its resistance will decrease with rise in temperature and it will draw more current, which will produce more wattage and hence heat. With more heat, the resistance will decrease, further resulting in instability of operation. Sixth, ductile. Since the material of heating elements has to have convenient shapes and sizes, it should have high ductility and flexibility. 7. Mechanical strength. The material of the heating element should possess high mechanical strength of its own. Usually, different types of alloys are used to get different operating temperature. For example, maximum working temperature is nearly 1000 degrees. And the materials are generally used for heating element that we will discuss here. So before that, we have to understand that why the good heating materials are required. Definitely, these 7 points are essential for a good heating material. Definitely the high specific resistance, high melting temperature, low temperature coefficients of resistance, high oxidizing temperature, positive temperature coefficient of resistance, ductile, mechanical strength. These factors is the important part that is indicating that why we need a good heating material for using a resistance heating or electric heating purpose. Now we will see what are the materials are generally used for good, considered as good heating elements. Nickel, chromium, iron alloy is the cheapest and most economical and stronger for temperature up to 950 degrees centigrade. Nickel, chromium, iron alloy is the cheapest, most economical and stronger for temperature rise up to 950 degrees centigrade. Nickel chromium alloy has not only good resistance to oxidizing up, but at the same time it has sufficient strength. On the other hand, iron chromium aluminum alloy has very good resistance to oxidation at high temperature but lacks strength. Nickel alloy, copper alloy is frequently used for heating elements. Operating at low temperature, it has virtually zero resistance temperature coefficients, which is most important property. Various forms of silicon carbide are used for temperature rise up to 1400 degrees centigrade. For still higher temperatures like platinum, molybdenum or carbon can be used as resistor. That means there are several materials there which can be used for electric heating purpose. Whatever the amount of the temperature rise, depending upon that we will use different kinds of material. If our temperature requirement is up to 950, then we can use nickel chromium alloy. If nickel chromium is very good resistance, so we can use it. But if we need much more higher temperature like 1400, we have to use silicon carbide. And more than that, we use platinum, molybdenum and carbon as a resistor. So that means different materials will create different amount of heating. So depending upon the material, the heating can be done. So up to this is for today's lecture of electric heating. This is just introductory part. In my next lecture, we will again continue about electric heating. This total lecture has been taken from the book of Sadhu and Das, and it is Utilization of Electric Power. You can follow any other books like J.B. Gupta or Patro or any other books you can follow. But this part is very, very important and very useful for our daily life and domestic purposes. So definitely we will go through this chapter and read on electric heating. Thank you all for listening to my lecture.